Hello, good morning, good afternoon, good evening. Welcome to you wherever you are. Thanks for tuning in. This is interesting stuff. It's an educational supplement, it's a little dive into a world of fascination. Today, we are looking at magnetic attraction. So, a magnet is a material or object that produces a magnetic field. The magnetic field is invisible to the naked eye, but it is responsible for the most notable property of a magnet, a force that pulls on other ferromagnetic materials such as iron, steel, nickel, and cobalt. So, you've probably got some magnets somewhere around your home, maybe in one of the rooms, maybe sticking something to the fridge, and these are the obvious magnets. But you've actually probably got thousands of magnets in your home. You're just not aware of them. Now, our planet Earth itself is a magnet. Crazy, isn't it? And I guess all the objects in the universe are attracted to each other or apply forces on each other in one way or another. So they all have some kind of element of related property there. And maybe that's what Tesla was studying when he was doing all his electric experiments. Remember, the Earth has two poles, the North Pole and the South Pole. And the rule of magnetism is that unlike poles attract and like poles repel. Yeah. So opposites attract is basically what they're saying. Now, a magnetic field is created by a movement of electrons within the magnet. The fact that the magnetism comes from this action also links magnets to electricity in what we call electromagnetism. They are two sides, basically, of the same coin. You want a bit more information? Here we go. There are two types of magnet, permanent and electro. In the former, the permanent, the magnetic field is fixed and will always be in operation. In the electromagnet, the magnetic field is only operational when the current is flowing. These different properties mean that different jobs are best performed by one type or another. And so the examples are that the magnet that holds your notes to the fridge, well, that's a permanent magnet. And the magnets that are found in most machines that we use, cars, stereos, televisions, computers, mobile phones, something that's basically everywhere around you. So those are the electromagnets. And so when an electric current flows along a wire, a magnetic field is created. And when you spin a magnet within a coil, you get an electric current. Knowing this and a little bit about electrons, those tiny little particles that orbit around the nucleus of an atom, knowing this explains how a magnetic field can be created without an apparent electric current. Yeah, how cool is that? There's so much happening around about us that we just automatically take for granted. Oh, look, this sticks to that. Oh, wow, that's cool. And then we sort of move on. We don't think too much about the science a lot of the time, and maybe we should. Maybe we should be more aware of what's going on in the world around about us. And scientists have been trying for hundreds, maybe thousands of years to look at the principle of magnetism and see if it can be applied to the world around about us, so that we can have some free energy. And that would be pretty cool. That would be pretty cool if somebody was able to do that, because I'm sure cheaper energy bills would be welcome everywhere. Anyway, some interesting little bits and pieces. You want some little bits and pieces? The Earth's magnetic power comes from the fact that it's liquid at the center, and that this causes it to be a massive electromagnet. Wow. Has anyone been down to the center? Are they even sure of that? I don't know. The magnetic pull is always strongest at the poles. Birds use the Earth's magnetic field as a way of navigating themselves on long flights. Cool. And there are actually not many materials on Earth that are magnetic. Maybe there's more out there in space. Maybe we need to go out and explore. Magnetism is actually light. Why do the magnets stick together? Magnets attract each other because they exchange photons, or the particles that make up light. But unlike the photons streaming out of a desk lamp or reflecting off everything you see around you, these photons are virtual, and your eyes or any particle detector can't see them. How do they know they're there then? They can, however, exchange momentum, and this is why things stick together. Well, this is why they stick or repel each other, basically. Like, here's an example. When a kid throws a dodge ball, they are exchanging momentum with the ball, and the thrower feels a slight pushback. Meanwhile, the targeted person feels the full force of the ball. Yeah, for sure. Yeah, there you go. Interesting, isn't it? And so basically, the last time you were playing dodgeball or basketball or baseball or football or anything with a ball, you were experimenting. You were experimenting with the forces of the world, the forces of the universe, the forces of gravity, the forces of nature. Yeah. So in gravity, the element of gravity, because of the size of the Earth, is also related to magnetism as well. Anyway, moving on. I want to keep it short. The world's most powerful magnets. The two biggest magnets reside in Los Alamos National Laboratory in New Mexico and in Florida State University. A big magnet in a university. Interesting. These two sister laboratories have magnets that can reach 145 Tesla respectively. I imagine that's some huge number. Not exactly sure personally. By comparison, junkyard magnets, the ones that lift cars, are about 2 Tesla. Okay, that's a pretty good comparison. The Los Alamos magnet is designed to generate fields that last only a few seconds, while the FSU magnet can maintain its fields for as long as the power is on. Each magnet is designed to perform different kinds of experiments. An interesting effect happens with the FSU magnet when there are diamagnetic materials, such as an aluminium canister, around. The diamagnetism creates fields with an opposite orientation to the magnet, so anything made of such materials is stuck in place. It's fixed. It's fixed. I wonder what experiments they do with these things. It's probably worth finding out. It's probably worth going online and seeing how it all works. Once upon a time, I went out to my workshop and I had all these magnets and I experimented with them. I tried to make like a little perpetual motion machine. Now that wasn't very successful. I did actually get a disc to levitate using magnets, which worked sort of quite well. That was a pretty interesting experiment, but it's quite fascinating to play with them, and who knows what we're going to achieve through science in the future with all the things that we know and all the things that we're learning all the time. So yeah, it's kind of fun as well. It's kind of fun as well to get a few magnets and play around with them, especially if you're a kid or a big kid like me. So that's it. Magnetism and the rules of attraction. Hope you enjoyed it. Let me know what you'd like to hear in the future. Wherever you are, whatever you're doing, have a great day, and there'll be more interesting stuff soon.